All right, so these notes are going to be pretty simple because what we're learning next is about the cross sections of 3D figures. And there's not a lot of math involved. It's more recognition and being able to picture something in your head. So the definition of a cross section is the two-dimensional slice that is created when cutting through a three-dimensional object. So the first example here is literally slicing something because I think that's the easiest. So we have an orange here, which would technically be a sphere if we were to classify this 3D figure. And so if you cut the orange in half, you can see that right there. We all know that when you cut an orange in half, you get a circle. So the cross section of a sphere, if you cut through the whole thing, is a circle. Now, if I take that half and I cut it in half again, so I make a quarter of an orange, then you can see that it would form that like half circle shape, which we could call a half circle or a semicircle. Half circle, semicircle, 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 one of the two. All right, next is a cylinder. And so if we think about this now, don't get confused by the shape of the thing doing the slicing. So I can see that it's a rectangle that's doing the slicing, but I'm just picturing this being like a knife or something. So if I was to cut into a cylinder, it would make a circle shape. So think about like cutting off the top of a Pringles can or something. What is the shape of the cross section formed if the cut is perpendicular? So if you were to cut it this way, and it would cut across the circle like that. If you can picture it, if you were to make a perpendicular cut, it would be a rectangle. And that's because a cylinder, when you talk about the side and the circle part, the base and the lateral side, they come together at a 90-degree angle. So you have a long side here and then a shorter side there, and that's going to make that rectangle. All right, over here we have a cube. It's not, well, it may not be exactly a cube, but in theory, the sides are all the same. So its width and its length and its height would all be about the same. And what they did is they cut it on the diagonal. They sliced it across the diagonal. And so that means that this length and this length are the same, but the diagonal would be a little bit longer. So when you make that cut across the diagonal like that, it would actually make a rectangle as well. If I made a cut that was parallel to the base, so remember there's a top base and a bottom base, if I was to make a cut parallel to the base, then it would be one side and the other side, and those would be exactly the same, and so that would make a perfect square if I was to cut it parallel to the base. All right, if I take a cone and I cut it parallel to the base right across the middle like that, again, don't be confused based on the shape of the thing that's doing the cutting, but if you make a cut parallel to the base, then here, if the base is a circle, the cut parallel to the base is going to be a circle as well. So we would say this is a circle. All right, what is the shape of the cross section formed if the cut is perpendicular to the base? So if I make a cut this way, then you just have to picture like a snow cone and what would happen if you cut it right down the middle. So we would have the sides are triangular, right? And then we have the bottom go straight across, so it would actually make a triangle shape. Someday I will have to redo this video and have lots of, like a Pringles can and a box and something that I can actually physically cut, but sorry you guys get gypped this time. Last, we have a square pyramid, and it says, what is the shape of the cross-section formed if the cut is perpendicular to the base? And I should have been a little bit more I should have clarified a little bit on here because there's a lot of different places you could make a perpendicular cut that would make different shapes. So I was thinking specifically about one that goes through the apex. So if you started up here and you made a cut, oh gosh, let's see if I can kind of draw this. There's like the middle, perpendicular to the base. That drawing is not great. But if you can picture it, if you made that cut, you would make a triangle. And that's because your sides are slanted, and then you have the base that's straight across. If you made a cut that was parallel to the base is a square, so if you cut parallel to that, it would make another square. It would just be smaller than the square that you had for the base. All right, now this is the interesting question. It says, where must the cross-section be formed if you want to have a trapezoidal shape? So for a trapezoidal shape, let's go ahead and cut it. Think about if we cut it straight across right here. And then what I'm going to do is I'm actually going to make a cut that's like perpendicular to the base right there, so if you can see it. There, I'm going to make a cut right there. And then kind of see this go across here. So if you can picture that, it's like I went straight down. I sliced into the side and I went straight down, and it would actually make that trapezoidal shape. So one perpendicular cut, if you went through the apex, would have made a triangle shape. But if I don't cut it through the apex, if I cut it on the side like that, then it would make that trapezoid shape. And if you see it, it kind of makes it, if we were to cut that piece off, that whole piece would actually be a triangular prism there. But if we were to just take a slice of it, kind of like taking a slice of bread, that slice of bread piece would be like a trapezoid. So really when we learn tomorrow, when we practice tomorrow, we're not going to be doing much math. We're going to be practicing recognition to see if we can see what cross sections we would get from cutting into different 3D figures.